Welcome back, everybody, and um, welcome to lesson 2 of this, the Steam boiler model. Last lesson we created this part, so we did all the pipes, right? All the pipes that we need for our model. This time we're going to start with the materials. The materials for our the starter for our materials. We're gonna do the circle, the spheres later. So let's start with the helpers, because we need helpers to be able to do our materials, right? So let's get started. So obviously we start with define simple material. So self-explanatory. It's a simple material. The parameters, like a material, it's just the simplest version that we can use for a material. So name, base color, 0.8, 0.8, 0.8. Base color is an equal sign, not a plus sign. 0.8, 0.0.8, 1. Metallic is 0.0. Rough is 0.4 and alpha is 1.0. Now, you may be wondering, what are these things? Because, well, they may, some of them you might remember, like, name obviously is lots of them, and then base color, well, it's the color. Metallic, how metallic it is. I spelled rough wrong. What about alpha though? Alpha. I bet you've never heard of alpha before. Well, I'm gonna show you. So, remember the site? We used it in a couple of our past videos. But basically, it just tells us about the parameters like base color, metallic, rough, alpha. So obviously we have base color, which determines the color, metallic, which determines how metallic it is. So higher the number, the more metallic it is. And it's at 0, it's not metallic at all. Well, yeah, because we want to show the water and things inside, so making metallic would be weird. Rough, I think roughness is, well, it's not exactly the opposite of metallic. You can see there are differences, like metallic is, the reflection is more blurry in metallic, but in roughness it's similar, and it's 0.4, which is, you can see over here at this, it says the scale is from 0.0 to 1.0. So 0.4 is like somewhere over here. And alpha, alright, alpha controls the transparency of the surface. So 0 is, it's practically invisible, and then it slowly goes up from there. You can see our alpha is 1.0, which means it's fully visible. So yeah, no problem with seeing the material. Now let's start with inside this. So mat. So we need a mat for every material. Dot new name Matte is, you know, the material, like we apply a matte to the object to make the material. Then matte.use nodes equals true. We want nodes. Nt equals matte.nodeTree, so we want to use node trees. So remember, nodes are the, well, you'll see. If you don't know what they are, well, you'll see soon. And if you don't know, or you can look at the previous videos, but I'll explain it again here. So BSDF equals nt.nodes.get principled BSDF. So nodes are like an element of the thing, the object. In principled BSDF, well, if you look at, I get this website from Blender I showed you like a few minutes earlier in this video. You look at the name, principled BSDF. So principled BSDF, so their inputs, which are these things. So yeah, so we're going to use this. And okay, so but if you want to like fully understand it, you might like really want to know what BSDF stands for. And well, it stands for bidirectional. I don't remember bidirectional. Wait, let me. It does bidirectional scattering distribution function. So bidirectional scattering distribution function. So it's a mathematical function that determines the probability a specific ray of light will be reflected at a given angle. So basically, it's a function that tells us like how the light reflects to get these parameters. Alright, so in its nodes, so part of nodes, BSDF.inputs base color, so color is part of the BSDF thing, and default value, so the default value of the base color is base color BSDF.inputs metallic dot default value, well, the parameters we defined earlier over here. The inputs roughness, the default value is going to rough, which we also defined over here already. The inputs alpha default value, because well, it's the default value, the value that starts first, and then you also already defined them, so yeah. Alright, now matte.blend method is blend if alpha is smaller than 1.0, else opaque return. So the blend method is blend if the alpha is smaller than 1.0, else otherwise it's opaque. So alpha, you can see, is not smaller than 0.0, but that might change. So it's opaque because, well, opaque means that you can't see through it, essentially. So we can't see through 1.0 alpha because that's completely opaque. Anything below 1.0 alpha will make it blend. So it's 1.0 right now, so it's opaque. Alright. Alright, next we're going to create material for one of the spheres. So I think it's the top sphere. And what makes this one different is that it kind of like splits the sphere, the colors of the sphere, because you know there's a white and blue version. Actually, I'm gonna get out an image of it. So let's say, oh yeah, here. So you see, the top sphere we have nothing, and then we have water. So I can make that into one material with this diff function, and what it's going to do is it's going to define a place where above it there's going to be this white, yellowish, and then below it's going to be the blue, representing water. So let's do def make height split matte name low color high color, and then the level is 0.25. And the low color and high color things will make sense. I mean, from the names you might be able to make an inference already. Okay, well, we're actually going to define it first in the comment. Below level is low color, which is the water, because water, obviously. So, low color and high color. High color is the color above this line over here. So high color is this color, and the low color is the colors below the line. And then the line is level, which we're going to define later. So below level is low color, above is high color, which is steam. So there's the steam boiler, so it's going to make steam. Right? Matte is bpy.data .materials.new name. So name. Matte.useNodes is true because we want nodes for this. Nodes is matte.nodetree.nodes link is matte.nodetree.links. And okay, so links. Actually, let's first code the node tree. Matte.nodetree. So I already know nodes. How about links? So if we go shading, let it run. It may take a while, but once we get into shading, oh wow, no, okay, it's very laggy. I'll just yeah, okay. So down here there will be some images. No, not images. There'll be like squares. Inside these squares are going to be words, and then you can link them. Actually, I used them in one of my old videos. I can get out for you. Wait, actually, never mind. I don't think I do so. But however, you can see there's nodes. So rename, show, hide. Actually, well, I'll show you once we do it. But there's going to be lines, boxes that will say like the level, and then it'll be connected to something called like the color. So we can adjust the level and then adjust like the above the low level and the high level things over here. The level over here, which will also adjust these things, which is pretty cool, and you will see that very soon. Okay. For n in nt dot nodes nt.nodes dot remove n. So um so off the bat you might notice that, well, there are a lot of n's. Well, let's break this down. So for n, so n is a variable in n for n and nt.nodes. So every node n and nt.nodes, nt.nodes you remove a n, and n is just a node. So now let's continue. Obj, so object, you know, because obj is the abbreviation for object, is nt.nodes.new shader node text coordinate. COORD is abbreviation for coordinate. Sep, so separate, nt separate. You might not know that one. Nodes.new shader node separate xyz. GT is nt.nodes.new shader node math. So GT is math, and then we're gonna have an operation. GT.operation is greater than. So if some of you may already see where we're going with this, we have separate xyz. So on the z side, so like the vertical side, like this way, note we have the object, and then if it's greater than this level, then it's going to be the steam, and then that's why we did the math, separate xyz, and then the text coordinate. Alright, now gt dot inputs dot default love value is equal to level. Wait, oh yeah, love was over here. Wait, sorry, my bad. Okay, so water level is this because it goes up to this line. Water level goes up to here, so that's the water level. So the way of mix is nt.nodes.new shader node mix RGB, so color, right? Mix the RGB to make the color. And then we have C1 is nt.nodes.new shader node RGB, and C1.outputs 0.default value is low color. C2, actually C2, let's make it over here. C2, the output default color is high color. So the color shader node of PG is just low color and high color. Yeah. And then BSDF equals nt.nodes.new shader node BSDF principled. And okay. That's it for today. We're gonna finish this def function next lesson. Hope you have a good day, and bye.